Hey, I'm Charlie Thompson, and this is a Google Earth and TopoMap video for the TopoMaps lab. And it occurred to me that a lot of the things that we do with TopoMaps are because we didn't have Google Earth. Like the whole point of a topographic map is to, through the use of contour lines and sometimes shading, to try to convey a sense of elevation and relief, so that you can tell by looking which parts of the landscape are flat, which parts are steep, where there's mountains, where there's valleys. And all of that was done using flat paper because we didn't have Google Earth. Well, now we've got Google Earth, so let's try to combine the two. And let's zoom in. This is Stewarts Point. It's north of San Francisco, north of Bodega Bay, north of the Bay Area. So let's go to Stewarts Point and zoom in, and we've got contour lines, and I'm going to turn on the index contour lines, make those a little bit darker. So those are every 200 feet, 600 foot, 800 foot. So this is the 600 foot contour interval. This is the 800. So this is 640, 680, 720. 760 and 800. So a couple other things about the contour lines where they are close together, and I'm going to turn on all the contours. So these are just showing the indexes, and you can see very faintly the intermediate contours. If I turn on the intermediate contours, you can see them a bit more clearly. So let's take a look at some of the features. So right here, it should be pretty flat, and if I tilt the screen, you can see that that indeed is flatter than this slope right here. Another important aspect is that streams. So let me turn off the contour so that we can see the streams a little bit better. So where a stream crosses a contour line, it makes an A that points uphill, alligators swimming uphill. So here's another example where you're going uphill, the contour intervals, in fact, let's turn on those. Yeah, the contour lines make a V pointing uphill, a V pointing uphill. If we take a look here, you can see a V pointing uphill. That's pretty good for that. So just looking at the map then, you've got a sense that the darker the lines here are so close together that it's like there's shading. And the lines here are so far apart, you can tell it's very flat there. It's not flat there. So if we turn off the overlay, and if I turn off all the contours, and we zoom in, we could see, well, let's turn back on the index. So is it flattish there? Yeah, that looks pretty flat. And then the parts that were really steep, yeah, well, maybe it looks steeper. So let's take a look at Yosemite. So we've got an older map, we've got a newer map. Let's take a look at just the newer map. A couple things I wanted to show you. Yeah, so now you can see really, for example, okay, so down here in the valley, you can see that the contour lines are really far apart and it's flat. And the places where the lines are close together, right there, for example, those are the places where it's steep. And so example, Half Dome itself, getting some sense, yeah, it's so steep that the image is just sheared off because it's so steep. So again, we've got, if we zoom in right here, you can see here's a stream flowing uphill, and the contour lines are indeed making V's as they point uphill. The other thing that I wanted to show you here is, so calculating out the elevation in the slides of Sentinel Dome, so this is 8,000 feet. So here to calculate the elevation of Sentinel Dome, we know that this is 7,800, this is 8,000 feet. This would be 8,040, 8,080, 8,100 feet for the summit. And then here the same, we could calculate it the same way. This is 7,800 right here on the index. Again, a 40-foot contour interval. This is 7,840, 7,880. So the summit is a half contour interval more, so that's going to be 7,900 feet for the summit. Okay, so let's go back to the slides.